Welcome to A Beginner's Guide to the C Programming Language. We have tailored this series of videos for those of you who are learning their first programming language. In this series, we will have a detailed explanation of each topic, followed by a practical show and tell to demonstrate the finer points. I hope that this will help you build a strong foundation in your understanding of C and basic programming principles. This understanding will also help you learn other languages with ease. Here is an overview of what to expect in this course. Firstly, we will cover the basics of programming and understanding of how a CPU and operating system works. We will show you how data is stored and processed in memory and the basic elements of the C language. Then we will discuss the structure of a C program, how to design and code programs using various programming constructs, discuss the software development lifecycle and the various tools that help in the development process. Finally, we will build a simple data structure from scratch and write a program that will cover the important concepts that we learned in this course. So welcome again to the first video of this course. Please subscribe to our channel, like and share this video. In this session, we will start with the basic question. Why should a beginner in programming learn C? Well, learning a low-level language requires you to learn the instruction set of a microprocessor. While this is good, you will not be able to program other CPUs because they have different instruction sets. So you would need to rewrite your programs for every type of processor you wish to execute them on. Also, programming in machine language is tedious and time-consuming. On the other hand, you could learn a high-level language like Python, which has very powerful inbuilt functions and data types. This would help you build very complex applications very quickly. However, what you want to do when you are learning your first programming language is learn the basics of programming and the best programming practices. That is why you choose a language like C. Now, C is a mid-level language. It is small, simple, and powerful. This makes C a great language to learn for first-time programmers. It will build your understanding of basic programming concepts that you can then use when you learn other programming languages. In this introductory video session, we will get a basic understanding of the Central Processing Unit, or the CPU. We will also discuss operating systems and the different types of programming languages. We will also understand how programming languages are converted to a form that is executed by the CPU. Just a brief note out here. Our discussion of the CPU and operating system will be high level and we will not get into details. I will explain concepts as they relate to the C programming language, leaving out other details. So let us begin with a look back at how computers have evolved over time. Computers have been with us for a very long time. Early computers were mechanical devices built with mechanical components. These performed simple functions like adding and counting. An example of a mechanical computer is the difference engine created by Charles Babbage. But computers rapidly improved with the invention of a transistor. A transistor is an electronic device that can store a single bit of data. Integrated circuits packed with transistors quickly replaced electrical and mechanical components within computers. Most importantly, they dramatically improved the reliability and speed of operations of a computer. The exponential growth of the power of computers was predicted by Gordon Moore, the co-founder of Intel. He predicted that the computing power of a computer would double every 18 to 24 months. This exponential growth resulted in the development of very powerful microprocessors that are at the heart of computers today. The microprocessor or CPU is a special kind of integrated circuit that is designed to perform a set of instructions. To extend the capabilities of the CPU, it is connected to other peripheral devices that provide it additional capabilities like external memory, interfaces to input and output devices, etc. The CPU and its peripheral devices is managed by three groups of connections. These are called a bus. The first bus is a data bus. It is used to transfer data bidirectionally between the CPU and the peripheral devices. The number of connections determines the width of the data bus and the data throughput of the CPU. You can visualize this as a multi-lane freeway. The more lanes on the freeway, the more traffic it can carry at a particular time. For example, a data bus that is 16-bit wide will have less throughput than a 64-bit data bus because, in order to perform a 64-bit operation, the CPU with a 16-bit data bus will need to transfer the data in 4 operations. Think of it as 64 cars trying to go through a 16-lane highway at the same time. They cannot. Instead, they will need 4 operations to pass through. However, a CPU with a 64-bit data bus will be able to do it in a single operation. Another bus used by the CPU is the address bus, and it is used to select peripheral devices for read-write operations and address individual bytes of memory. Think of this as a pin code in an address. Every location has a unique pin code. If the pin code has only 2 numeric digits, then it can address 100 unique locations. If it has 6 digits, it can address 1 million unique addresses. So, bigger the size of the address bus, the more memory it can address. CPUs with 16-bit address buses can access 64K of memory, whereas a 32-bit address bus can access 4 GB of memory. Now, the third bus is the control bus, and it contains specific connections that enable read writes and other control operations. We will not bother ourselves with details of the control bus. So we have seen how a CPU connects to its peripheral devices using the data, address, and control buses. Let us now see how a CPU operates. As I mentioned earlier, every CPU is designed to execute a known set of instructions. These instructions are encoded as 1 or 2 byte values called opcodes. So each instruction, like add, move, multiply, etc., have corresponding opcodes. An instruction in machine code consists of opcodes and additional information required to execute that instruction. Each instruction is executed within an instruction cycle, which consists of 4 parts: the opcode fetch, decode, operand fetch, and execute. An opcode fetch is when the CPU fetches the next instruction it needs to perform from memory. This opcode is then decoded and determine which instruction needs to be performed. If any further information is required, then that is fetched in the third cycle. And finally, the instruction is executed in the execute cycle. A CPU is executing instructions continuously from the time it starts up till it's shut down. This is synchronized via a clock signal. Every instruction cycle takes a certain number of clock cycles. A clock signal determines the speed of the CPU. The higher the frequency, the faster the CPU performs. Now, when a CPU executes an instruction, it needs some internal memory. This memory is called registers. Different CPUs have different names for their internal registers. In the 8086 family of CPUs, the different types of registers are as follows. Data registers that store the data on which operations are performed. These are the accumulator, base, count, and data registers. The segment addressing registers are used to store the starting address of blocks of memory called segments. The third kind of registers are used to store an offset address. These are the stack pointer, base pointer, source and destination index registers. The segment and offset registers together work as a pair to address a byte of memory. For example, the stack segment and the stack pointer address a byte of memory in the stack segment. Also, the code segment and instruction pointer registers are used by the CPU to get the address of the next instruction to be fetched from memory. So let us summarize our discussion on the CPU. The CPU is driven by a clock signal which drives an endless loop of fetching and executing instruction cycles. It uses the address bus to address memory, the data bus to transfer data, and its internal registers to store data when performing instructions. We will return to this discussion on the CPU when we talk about the data types and storage classes in C. The next topic in our discussion is the operating system. In earlier times, programming a CPU would mean coding in machine language. This was a tedious undertaking requiring highly skilled technical staff. All this changed with the introduction of an operating system and programming languages. An operating system is the first program to be loaded onto a computer's memory after it starts. It manages the resources of a computer, including memory, disk, and other peripherals like network ports, printers, etc. It also interfaces with the user, making it easy for the users to operate the computer. As seen here, it's an interface between the hardware and the user. In addition, the operating system has within it many system functions that your application can reuse. These functions provide various functional, security, and system level functionality and are accessed by making system calls to the operating system. This makes it possible to write large applications without having to reinvent the wheel. Another function of the operating system is to provide a proper environment for your programs and manage the execution of processes on the computer. In an operating system like DOS, only a single process can be executed at one time. These are single user, single tasking systems. On the other hand, Windows is a single user multitasking operating system, which means that it executes multiple processes at the same time. It does this by time slicing each process's access to the CPU in a round robin fashion. Finally, you have multi user multitasking operating systems that are prevalent in servers and mainframe computers. These allow multiple users to execute multiple processes on the computer. They are very complex systems and often used by large applications that many simultaneous users can use. So, to summarize, an operating system manages resources, determines how processes are executed, and provides various system functions for user programs to reuse. In our course, we will utilize these system calls to perform common tasks that are required within applications. Finally, let's discuss programming languages. Programs provide instructions to the CPU. At the lowest level, you have machine code that defines the instruction set of the CPU. It is the only language that the CPU understands. As mentioned earlier, programming in machine code is very tedious and takes a lot of time to code and test. And more importantly, it is challenging to maintain. Then you have other low level languages like assembly language, which provide symbolic commands that can be used to write programs. This is a little better than machine code, but still suffers from the same drawbacks. Languages like C provide a more human friendly programming structure, making it easy to read and maintain in the long run. Some languages like Python provide inbuilt functions and data types that can be used to develop large functional applications very easily. Now, each language has its advantages and disadvantages. Low level languages are simple to learn but are not portable and are tedious to program. High level languages can be used to develop complex applications easily, but they do not provide you with the flexibility to customize or to create your own data structures and implement efficient customized algorithms. The C language is very flexible, extensible, and powerful, but it takes more time and skill to build applications. Now, every language has three components: a vocabulary, syntax, and semantics. Vocabulary is defined by the keywords and other symbols that can be used in the language. C is a minimal language because it has just 32 keywords, which makes it simple to learn. Syntax is the grammar or the language rules. It defines how program statements are constructed. Finally, semantics is the well defined meaning of each program statement in the language. You can simply learn a language by knowing its vocabulary, syntax, and understanding its semantics. Unfortunately, that will not make you a good programmer. because programming is a skill that goes beyond these three elements. It involves the understanding of the development process, writing algorithms, creating data structures, and using different tools effectively to develop optimized and easy to maintain applications. Irrespective of the language you use to write an application, it needs to be converted to a form that the CPU or runtime environment can understand. This conversion is done by programs that are known as interpreters and compilers. An interpreter reads the source code and checks the syntax of the program. It then executes the instructions specified. It does not generate any output file. As a result, every time the interpreter executes a user program, it repeats this process again and again. This is an overhead and reduces the speed of execution of the target program. On the other hand, a compiler will read the source code and through a multi-step process will convert the entire source code to an executable format. The converted code is stored in an executable file and can be executed later without the source code. Since the executable file is in machine code, the CPU can execute it directly and it is very fast. Note that compilers are platform dependent. You can have a C compiler written for the Windows platform, the Unix platform, or the Mac OS platform. While the source code may be portable from one platform to another, the executable file is not, and you may need to recompile the source code in order for it to work. Let's dig in deeper into the compilation process. The compilation process converts a computer language to machine code through a series of steps. The first step is lexical analysis, which involves pre-processing the source file and breaking the source file into a series of tokens that can be used in the subsequent processes. The next step is of syntax analysis, where the language rules are checked. If the source program does not follow the syntax rules, then syntax errors are generated. If the syntax analyzer processes the file successfully without any errors, it generates a parse tree and a symbol tree. After syntax analysis, the semantic analyzer will parse the syntax tree and symbol tables for consistency with the language definition. The final three steps in the compilation process are used to generate machine code, optimize it, and create a relocatable object file. The compiler generates object files which are intermediate machine code. These object files are linked together by a linker to create a single executable file. To be more specific, a linker integrates all object files, library modules, and other resources and creates a final executable file. Since C is a compiler-based language, we will use tools like compilers and linkers. Finally, the third class of languages is part interpreted and part compiled. An example of this is a language like Java. A Java compiler will compile Java programs into an intermediate bytecode. This bytecode can be executed by a runtime environment like the Java runtime. The advantage of this approach is that the bytecode is then portable across different platforms, since each platform will have their own runtimes. So, programming languages make it easy to program and maintain an application. They can be interpreter based, compiled, or executed in a virtual machine environment. We have come to the end of our short discussion on the CPU, operating systems, and programming languages. In this video, we have covered some of the basic topics that we will need in our programming course. Please join us in our next video in the series. We will look at how data is stored in computer memory and how different types of data like characters, strings, integers, and real numbers are represented in different number systems. Again, please subscribe to our channel and enable future notifications. See you soon in our next video.